All right, we're live, Verge. Welcome to
Thank you,
Friday.
Mark. Thank you. And welcome back, everybody. This is our third lesson of AP Live, and we're going to today do section 7.3, sketching slope fields. And before we do that, just in case we have anyone who hasn't yet watched any of the previous lessons, we're going to do some introductions and also some overview of where we hope to go in the next several weeks. So my name is Verge Cornelius, and I teach at Lafayette High School in Oxford, Mississippi. Yesterday, I said something about, it's the only place in the world that says it as Lafayette instead of Lafayette, and I was corrected. One of my colleagues said, "Oh no, in Georgia they say Lafayette also." So I'm learning stuff every day for sure, and I'm getting very good at Zoom. Go ahead, Mark.
I am Mark Crowley, and I'm from Ryan High School in Denton, Texas. And Verge and I know there's been some questions online as well of does this end after this week, since there's only 3 videos posted, and we are in for 4 more weeks. So through May 1st, we're going to keep this going. So if you're like, when are we going to get to the review? We've got lots of time, folks.
All right. So with that in mind, the next several weeks leading up to May 1st look like this. We are going to be teaching Unit 7 differential equations because many students left off by not learning that in their AB courses. School got canceled or they went on spring break and didn't go back. So we are going to work on Unit 7. Then we are going to work on Unit 8, selected topics of applications of integrals. We're going to do 8.1, 8.2, 8.3, and 8.4 from the CED, which is that big binder that teachers have access to. And I believe students can access it as well. Am I right about that, Mark?
Yes, and there was a link in yesterday's folder to that PDF as well.
Okay, great. So when we refer to 8.1, we're not talking about a particular textbook you might have. We're talking about the College Board's curriculum exam design, the CED. And we're going to tie those units back to previous units. That's why we selected those 4 units. And then even as early as next week, actually, we're going to be reviewing and we're going to be weaving in test taking strategies. Once April 3rd hits, we're going to know a lot more about what this online test is going to be that only has free response questions. So we'll be reviewing all topics and doing some test taking strategies and tips and things like that leading up to the exam. This is a new feature, everybody. It's so exciting. We have a new slide called Daily Corrections and Oversights. And hopefully this is only going to happen occasionally, but so far we're 2 for 2. So if we make a mistake, we are going to tell you what our mistake was the next day in some form or fashion. So yesterday, as I was working, you can see that I said that 9 plus 3 was equal to 15. Bad. 9 plus 3 would be 12. And then 12 minus 6 is still not equal to 0. So it kind of was, one of those mistakes where I worked through it quickly and I didn't even catch it, obviously. But thank you so much to those folks who told us about the mistake. And maybe you'll find another one today. They are not planted. They are completely organic. So
and I would like to give a shout out to a specific AP bio teacher that my wife caught it because she's watching our videos every night because she's a calculus nerd. So.
Yes, that's fabulous. And one of my students caught it and texted me immediately. My phone is off right now, so I didn't get it until the end. But yeah, we had several different parts of our lives, including spouses, obviously, who caught that mistake. So, okay. So this is our lesson overview today for Friday, March 27th. We did our introductions. We always want to welcome everybody back and also welcome any first timers, teachers, students, and colleagues to this lesson. We're going to spend about 5 minutes in our warm up, and this is going to be from the last lesson's materials. So if you have those in front of you, if you printed it, that's great. You're going to take a look at that momentarily. And then our lesson is sketching slope fields. And we'll wrap in with that some guided practice as we go, and then do a final wrap up and further resources and what you might find in that Dropbox this afternoon. Okay. So this warm up right here is one of the problems that we did not work yesterday. And this was the verifying solutions to differential equations, 7.2. And it reads like this, and it came directly from that Dropbox handout. For what value of k, if any, is y equals e to the negative 2x plus k e to the 4x, a solution to the differential equation y minus y double prime divided by 4 equals 5e to the 4x. Now, if you're watching this live, we're going to have about 50 seconds to work it or to find your materials. If you're not watching this live, if you can go ahead and pause it for yourself and work it right now. We're going to show Mark's work and also his answer in about 45 seconds. And because we don't really want any dead air time, our new technique is going to be that if you are watching live, you're just going to go ahead and turn down the volume right now. And actually, I'm going to sound like this because I'm going to tell you a joke. Okay, here comes the joke. You know, my AP Stats teacher yesterday called me average. Wasn't that so mean? Okay, about 15 more seconds and Mark is going to show you his work.
Thanks so much for that.
You know, we're going to get like 60 stupid dad.
I'm actually quite all right with that. My 12-year-old would love it.
Okay, we're going to people are going to be like texting him right
people
now.
want to find me and figure out how to send me a math dad joke. That would be fantastic.
All right, Mark, you can show your work.
All right.
And you can, if you want to narrate it a little bit, this instead of me kind of doing all my handwriting through it, we thought this might be a little more efficient.
Okay. So this was our given, of course, our solution that we're verifying. And we're trying to find the k, sorry, not verifying, our solution that we're trying to find the k for this. So I found my y prime. I need my second derivative. So there was a chain rule of a -2 when I took the derivative of e to the -2x, and a chain of a 4 when I took the derivative of e to the 4x. K is constant, so it's just along for the ride. Second derivative, another -2 chains out, another 4 chains out. And so my second derivative is 4e to the -2x plus 16k e to the 4x. When I plugged in, I did rewrite this divided by 4 as multiplying by a fourth, because I didn't want to have a giant fraction within this statement. I know when Verge and I were comparing, she'd put it over the 4. Personal preferences. I distributed the -1/4. We got these e to the -2x's that cancel out or have an opposite, so they add up, they sum to 0. And then I've got this -3k e to the 4x equals 5e to the 4x as my final equation before I go ahead and solve for k is -5/3.
Excellent. So that was answer choice A, I believe. Yes?
Yes, it was.
Okay. Excellent. All right, I'm going to go ahead and grab the screen now so that we can start on our lesson, which is the sketching slope fields. So this is what I write to myself every afternoon so that when I come down to my desk here, I know what day it is. You know, I made that mistake on Wednesday. But anyway, Friday, day 3 of AP Live, and this is my very high-tech notes right here. Our title is Sketching Slope Fields. And you don't probably know what a slope field is yet, unless for some reason you were able to learn this before spring break or before March. But a slope field is defined as a graphical representation of a differential equation on a finite set of points in the plane. So what's going to happen here is that we're going to have a differential equation, and we're going to go ahead and draw little line segments at each of these integer pairs that will represent the slope at that moment in time at that integer pair. If you went to the Dropbox yesterday, you saw that we did put a whole handout of these dot pages there, or dot paper there. And we also put a handout of these different examples right here. Okay, so one
Verge,
page.
I'm going to go ahead and steal you for a second.
Hi, Bob Ross.
Hey. So
Happy little math problem.
these two, yes, we don't make mistakes. We have happy accidents to discuss the next day.
Yes.
These are and to learn. Yes. These are the two. These are both in the 7.2 shared folder. Of course, there will be duplicates of them in the 7.3 folder by about I guess 2 Eastern, but within 15 minutes of the video ending.
Probably
Virgil, you want to grab
3:15.
that back?
Yeah, but probably about 3:15 Eastern. But anyway, okay. Because I think it's 2 Eastern right now, right? Okay,
Yeah,
I'm
3
grabbing
Eastern.
that. Yeah. Okay. So in any case, what we're gonna learn today is we're gonna learn how to sketch a slope field. And so we're gonna start by using this example right here. And these come from Nancy Stevenson, who's been a long time AP teacher. She taught at 2 different high schools in the Houston, Texas area. And she served on the test development committee in the 90s. And she is just fabulous. She's a close friend of both of ours, and she gave us permission to use these materials. But they're really, really clear. You know, you've got your differential equation here, dy dx equals x plus 1. And then there's this whole set of points on the dot paper that are all at integer pairs. So for example, this point right here where I'm pointing is at 1, 2, whereas this point right here is at -2, 1. So the way I'm going to do this first one is I'm just going to really think about the different slopes at those individual points. So I just said the point 1, 2. And I want to think about what the slope is. What's the dy dx? Dy dx is the same as the slope. So when x is equal to 1 and y is equal to 2, dy dx for this differential equation is going to equal 1 plus 1, because the x is equal to 1 or 2. So at the point 1, 2, I want to draw a line segment that's positive in its slope and also somewhat steep, a little bit steeper than 45 degrees, which would be a slope of 1. That other example, for example, when I have the point -2, 1, that would be here to the left 2 and up 1. And my x value is -2. Okay, so -2 plus 1 ends up being -1 for my slope. So I want to draw a little line segment that's got a negative slope, and it's got a slope of approximately -1. So this particular differential equation and the slopes that it's generating depend only on the x values at each integer pair. So this is pretty tedious to go through and do every single point. So what mathematicians do is they start looking for patterns. They start thinking to themselves, well, if the slope is equal to 2 at 1, 2, then it's probably equal to 2 at 1, 0, at 1, 1, at 1, -1. Any of these places where x is equal to 1, the slope is equal to 2, the dy dx is equal to 2. So I'm going to draw kind of a steepish positive slope here for those little line segments. One thing that mathematicians also look for is they look for slopes that are either 0 or undefined. And this one has some slopes that are 0. If x is equal to -1, for example, this point here, -1, 2, let's just say, which is this point right here, then dy dx would be -1 plus 1, which is 0. I'm starting to not show my steps, but you guys are all really smart. I know you know what I'm talking about. So I've got a slope of 0 there, so I draw a little tiny horizontal line segment, and that's going to be true going all the way down, wherever that x value is equal to -1. What about what's going on right here at this point? What do you think, Mark? At this point here, the point 0, 2.
Sounds like x is 0 to me.
Yep. So what's the slope?
So 0 plus 1 on Fridays in March is 1.
Yay! So there's that little 45-degree angle there for your line segment. And that's going to be true everywhere where x is 0. And everywhere where x is -2, I can kind of stay with this logic here in terms of my slopes.
Virg, you mind if I jump in with just some test
Yes,
observations?
absolutely.
Uh, Yes, I want to take the share. All right. And I do my table. It's still a tabular method, but I just don't lay out the T chart like Verge does. But here's a very similar layout. But what I wanted to say is, if this shows up on the AP exam, and again, we're waiting to next week to find out what exactly is going to be fair game, but these have shown up on the AP test. And like Verge said, we're looking for patterns, but also obviously mathematicians use technology to generate much larger ones. So on the test, you're only going to be doing 6 to 9 points ever at a time. One of the things that I like to do on this is I have a scale. You don't get one of these during the test. All you have is a pen or a pencil. So just aim, like picture a point that's 2 up and 1 over. And even if you're sitting over here and we find out that it's a point off, that, try to like just make an invisible point that you're aiming at. Because I know Verge said kind of steepish, but each one, I kind of just visualize that line and then grab a segment of it. Because I don't know if the tangent line exists there, but for right now it does.
Okay. I never thought about it that way. That's excellent.
Oh, well, thank
I
you.
always think about here, and I always think about, I know the tangent of 45 is equal to 1, so I always think about a slope of 1 has, assuming the x and the y are by the same scale, a slope of 1 is going to have an angle of 45 degrees. So that's how I think about it geometrically, and you're thinking about it as extending the line like that. It's really cool.
By the way, I just got a text message from one of our colleagues who said up to 12 points on the exam.
Oh, okay.
But
You mean in terms of like what they would
in
actually
terms
have
of
to
in
fill
terms
in?
of past AP free response,
Okay.
yes.
Okay. So I'm going to go ahead and steal this again
Yes,
if I
please do.
can. Yep. And you can see here that there's definitely some symmetry going on and things like that. So there's kind of a mirror image happening. And then over here, when x is equal to 2, this would be a slope of 2 plus 1, which would be 3, which is fairly steep, but we absolutely do not want to make it vertical. We're going to talk more about that in just a little bit. And so what I think what Mark is saying is we can just bag the rest of those points because we've already graphed way more than we needed to. Okay, second example. Again, it's coming from Nancy. Is this dy dx is equal to 2y? So second example, same Nancy, same handout, dy dx is equal to 2y. And in some ways, this is similar to the previous example in that I'm only looking at one variable here on the other side of the differential equation. So all of my slopes that I calculate are going to depend on which value, the x value or the y value. That's correct, the y value. All
Sorry.
right.
No,
I'm kidding.
didn't know if you were waiting for the imaginary voices or for mine.
Yeah, I know that some of my students are talking at the screen right now. They're good. Okay, so for example, here, when at this point right here, the point 0, 1, the y value is equal to 1. So the slope would be 2 times 1, which ends up being 2. So that's going to have a slope of 2, fairly steep. Like Mark says, he imagines another point that's up 2 over 1 that he could connect to if he extended that line segment. However, if I had the point, let's see, -2, 1, this point right here, oh, that's going to be, the y value is 1. So that's also going to be 2 times 1, which is 2. So all of these going across are going to have the same slope of 2. If I can draw it. This is how mathematicians do it. They go fast, they notice a pattern, then they kind of notice it all for all of them. You can make a huge table, but and you'll get the right answer, but it's kind of quicker to look for patterns. Okay, what's happening at, I don't know, what's happening when y is equal to 2, like at 0, 2? Then my slope is steeper. Just wanted to use the eraser. Kidding. Okay, so there we have a steeper slope of 4, and all of these slopes here when y is equal to 2, whether it's at 2, 2, 3, 2, 1, 2, these are all steeper than before, but still positive, of course. That one looks bad. All right, so what's happening below the x-axis? Below the x-axis, it's like at 2, -1, my formula says the slope dy dx is equal to 2 times y. So 2 times -1 is -2. So that's going to have a slope of -2. And anywhere that y is -1, we're going to have a slope of -2. What's happening along the x-axis here? Maybe some of you guys have already calculated that. Mark, can you describe what the slopes on the x-axis are going to be?
A whole lot of nothings.
A whole lot of nothings? Like, should I put them there, or should I not put them there?
There's a symbol for nothing. I was thinking the value 0. That's
So a 0 slope.
So we're going to have some horizontal line segments.
Yes, all horizontal line segments. Exactly. Exactly.
And that does bring to mind that maybe somewhere along the way this thing's asymptotic.
Yes. In fact, if you one thing that we're going to do is we're going to kind of look back at these slope fields and kind of interpret them and think about what potential solutions to those differential equations could be based on what we're seeing in the slope field. So it seems like what Mark is saying, there's some sort of asymptotic behavior happening here at the x-axis, and perhaps something going down like that. All right, let's look at a third one. This is number 3, actually. Unlike yesterday where we started with 0 and then skipped 2, all kinds of craziness. So this one, dy dx is equal to x plus y. So now our slope depends on, let's see, our slope depends on both the x and the y being added together. That's going to create our slope. So at 1, 1, for example, this point right here, my slope would be 1 plus 1, which would be 2. And then at, let's see, 1, 0, which would be right here, my slope would be 1 plus 0, which would be 1. There goes my 45-degree angle again. So this to me seems kind of tedious because like I can't be like, well, for here it's all like this and for here it's all like that. Oh, but there is something going on where I can say, oh, where is the slope 0? What's the nature of the points where I'm going to be able to draw a horizontal line segment? So Mark, go ahead and give me one of them.
Well, if I do x plus y equals 0, it looks like they need to be opposites. So let's go 1, -1.
1, -1, I can draw a little horizontal line segment. 2, -2. 0, 0. -1, 1. -2, 2. Like that. At -1, 0. I can go ahead and draw a slope of -1. Is there anywhere else I can draw a slope of -1?
Well, if either coordinate is one more, has an absolute, I guess, absolute value 1 more than the other and they're opposites, if we want to try and math speak it. So like -2, 1.
Yep.
And -3, 2.
Yep.
Oh, it looks like they're riding along a 45 there. Does 0, -1 work? And 1, -2.
Right.
Ooh, I wonder if that 45-degree line will work on other ones.
Huh.
This is unrehearsed too. I'm
Completely
thinking
unrehearsed.
I'm thinking 0, 1
during our prep time, like change our background, obviously, which I'm still not able to do because I have to do an update this weekend. Watch out for a new background on Monday. Tune in then.
You end up ordering a new laptop. If how about 0, 1? Yeah.
Oh, 0, 0, 1. Okay,
those are going to be our
like
1
this
slopes.
One.
Yeah. So then -1, 2.
So then -1, 2. Ooh, look at this diagonal.
So this negative pi over 4 line here is coming in really handy.
This is like ugly though. I don't know. To me, it is
It's
anyway.
it's still loved.
I'm not saying it's not loved. I'm just saying it's ugly because I'm not seeing a particular solution reveal itself to me like I did in the first two. Like I could say, oh, I could see this
Oh,
kind
this
of
is
family
definitely not one of the family of functions we play with all the time, is it?
No, it's not. Okay, what's happening at -1, -1? A slope of -2, perhaps?
Yeah.
Okay, and then a slope of -3 here. Slope of -2. Oh, that's nice. I can do a slope of -2 there and there and there.
Yeah, all those lines parallel to y equals -x are going to come in really handy.
Okay, and then here, this is -3, slope of -3, slope of -3. Okay, I think that's enough. I'm done. I'm done. That's enough for now. I think that looks okay. I have one for everybody at home to try. It's number 4. And again, I'm only going to give you a minute because we don't want too much dead time. But we know that many of you are actually not watching live. You're watching later on when you have time to watch it. So you can press pause. Wait for me to put the thing up here first. But you can press pause and then take your time to create the slope field based on the differential equation. And then in about a minute, we're going to have Mark reveal his slope field and talk about it. So there's our example number 4. It says dy dx is equal to 2x. And you can go ahead and create the slope field.
All right, this is number 4. So I don't get to pause it. This isn't fair. All right, so
So we've got about 40 more seconds on this problem. For those of you watching live.
oh man. Definitely should have prepped ahead of time on this one.
No, it's fine, Mark.
I don't want to hear from Oro Valley. He knows who he is.
Oh, I know who that is too. Busted.
Yeah, we're about to see how good that 30-second delay is before I get a text.
Okay, whenever you want to reveal your screen, Mark, and maybe you only have it halfway done, and that's fine. That's probably true for the people watching as well. This is a lot of points in this lattice of points right here. But truly on an AP exam, at least prior to 2020, you would only need to sketch maybe 6 or 9 of the points. It would be indicated.
Yeah. All right, I'm trying to share back. There we go. All right, that's actually the last one, but here's this one.
Yay! Looks so good.
I just got the text from Chris, so there's our live delay, folks.
Yeah. That looks so good, Mark. Anything you want to comment on for?
No, other than I started off way too fast, and I saw the 2 times 0 was 0, and I immediately started laying them along the horizontal.
Oh.
So this is why I need to have a pencil or invest in the cool pens like my friend Verge has.
Oh, I know, and I can send
but
you.
Fortunately, I had 3 copies. So there was the abandoned, and then we jumped in with another copy.
Okay, so here's my question to our folks at home. I think that looks excellent. We've got the one that you all just created, and I'm just going to put a mock one up. I'm going to steal that screen in just a minute. I just want to, these are the kind of things I do in my classroom. And of course you can't really do this virtually, but I'm going to try. This might be a total fail. We'll find out. Happy tree. Okay. Yes, mistakes. They're just, what are they? Happy accidents or something like that? Okay. So like these are our 4. This is one that I did earlier, just practicing so you can see it's in pencil, but it's very similar to that. Dy dx equals 2x. So out of these 4, if I kind of said, well, which ones seem to be of the same type or family or same thing going on, just even looking at the pictures, not looking at the differential equations, just looking at the slope fields. Which one do you think, Mark? Also unrehearsed. I come up with questions a lot, just because it kind of makes connections for me. Which ones seem the same to you or similar?
The first and the last.
Yep, agree.
Although I respect the group that looks at 2 and 4 have these horizontal trends as well, but
Yep. Okay, good. We're gonna do another one, which is number 6, and it's another one that has 2 variables in the differential equation, the y and the x. So it's dy dx equals negative y divided by x. There's some other issues that kind of come up in this one. So we definitely want to talk about those, because not every single one of these little dots, these integer pairs, will actually have a little line segment on it. Okay, there's going to be places that are going to need to stay blank, not because I was lazy, like on the other one, like here these stayed blank because I was lazy. Okay, that I was lazy, I just didn't want to do those. These are going to stay blank because we actually do not put a line segment at a place where we have an undefined slope. So I'm giving you a lot of hints right now, but you might be thinking to yourself, ooh, I know where that's going to be. Okay, so dy dx is equal to negative y divided by x. So for example, here at 1, 1, I always start like this. I might not start like this actually like on paper, but I start like this in my mind. I pick a couple points and see if I can figure out the pattern. Okay, so what is my dy dx slope? 1, 1. Well, it would be negative 1 divided by 1, since my y value is equal to 1 and my x value is equal to 1. This ends up being negative 1. So I'm going to draw a little negative 1 slope there. What about what's happening at 1, 2, for example? That's this point here. Negative 2 divided by 1 is negative 2. So a little bit steeper there, but still a negative slope. Up 2 over 1. Okay, it's giving me some ideas. Are there any other places where I might have a slope of either negative 1 or negative 2, I wonder? Well,
y and x have to be equal value, right? Equal absolute value. So
like here at negative 1, negative 1, this point right here, this would be negative 1 divided by negative 1, or negative 1. So that would be like right here. That's making me think that something else is going on here. I'm just like sketching that without calculating it. Is it right, Mark?
Yes.
Yeah, because of what's happening with this opposite signs in the quadrants.
Yeah, well, along y equals x and along y equals negative x, yeah.
Yeah, and so there's going to be some mirror imaging going on here.
Yeah, there's going to be a lot of symmetry.
A lot of symmetry. Okay, so here at 1, negative 2, this is what so it's going to be negative, and then negative 2 divided by 1, which ends up being positive 2. So that's going to be positive 2 right there. And then here it's going to be a negative 2. Okay. How about along the y-axis? Pick a point.
Oh, 2, 0.
That along
0, 2. Sorry, 0, 2. Oops.
0, 2. Okay. So 0, 2. So negative 2 divided by 0.
Uh-oh.
Division by 0 is undefined. So any time that I have an x value of 0 that's in the entire y-axis, I cannot put a line segment. No vertical line segments, nothing. However, along the x-axis, so like at 2, 0, what Mark had originally said, This would be negative y divided by x. So negative 0 divided by 2 is going to be 0 divided by 2, which is 0. So that would be a little horizontal line segment there. And at 3, 0, and at 1, 0, and at negative 3, 0, and at negative 2, 0, and at negative 1, 0. And what about the origin?
0 over 0, I believe, is undefined.
Still. Okay, so this one's still nothing at the origin. Nothing at all on the y-axis. Is
Verge,
your graph,
you want me to grab
more
it?
complete? Yeah, is
Yes.
your graph more complete than mine? Okay, good.
Wow, that's weird.
Is it not grabbing?
It wasn't giving me an option to grab my camera. Okay, I'll do my screen, I guess. Okay. Are you seeing that?
There you go.
Oh, I missed one. All right.
Yeah, good. Really good.
Okay, go ahead and grab that back, because.
Okay. Well, no, I like this.
Oh, okay.
I just want to say a couple of things, just because Mark and I have both read AP exams for a long time, and some of the teachers and students out there might not know that. But some of the things that students definitely mess up with while they're taking the exam is they first of all, what we emphasized about, you don't want to put any vertical line segments where the slope is undefined. And then another thing is sometimes students make line segments that are all kind of crashing into one another. So we want to have these tiny line segments that are not touching any of the other line segments. And then
I was just gonna say, in theory, there's an infinite number of possible tangent lines in here, and we're just trying to highlight specific ones. So you want to keep them discrete.
Okay, good. And what about students like actually writing their slopes, numerical values right onto the actual slope field?
Traditionally, we ignore it.
Okay, okay,
So,
I didn't remember. Okay.
yeah, and also they won't ask you to evaluate along, like, these dots wouldn't be here on an AP exam. I don't think they've ever asked the students to sketch a slope field. Normally they would just be blank. It would say, like, the 6 dots, and you would see those 6 dots.
Yep.
So.
Okay, all good information. All right, so we do have one more that we're going to go ahead and do. I was gonna go ahead and give it as kind of like an assignment or suggested practice, but I think we have time now, and I'm going to explain a little bit more what you're going to find in the Dropbox. So, and
go ahead and grab this back.
I am. I'm
Okay.
trying. It's weird. It isn't grabbing back right now, is it? Well.
Oh, did one of us?
I'm trying it again.
There we go.
I got it. Okay. All right. So this is the one that I'm talking about. And it's dy dx equals y minus 1. And we're going to give you about a minute to do that. If you're not watching live, of course, you can pause and do it for yourself. Dy dx equals y minus 1. And we'll have Mark show his, if you don't mind, Mark.
Nope.
Once the minute is up.
My hand has not started to cramp up yet. So. I'm gonna, but warn me before you bring me back, because I just moved my camera to get out of the way. All right. Interesting. Definitely some patterns on this one.
And in my own classroom, one thing I would definitely say is, which one, without even sketching it, which one should it probably remind us of when we're finished? And then when we are finished, we look at it and say, oh, I was wrong, or yes, I was right, things like that. Notice how in this differential equation, there's no division by a variable. So every single point here should have a line segment
In play, should be in play, I guess.
Every point is in play. That's right. Okay, you ready, Mark?
Yes. See if it'll let me share this time. It still does not want to recognize that my camera.
I just did a stop share, so maybe that helps. I don't know.
No, what's weird is it's not the software is not showing up. I'm sure it's something I have to reboot to get, but there we go.
Great. So, yeah, go ahead, Mark.
I was just gonna say, the one thing I just, mentally doing what Verge was doing with the table is looking at, 0, 0, 1, 0, 2, 0. Those all have a 0 y, and the only variable that this is taking action in this expression is the y. So I knew all along that it was going to be -1. And that was when I first said, oh, there's a pattern. And then obviously 1 minus 1 is 0. Getting steeper as y gets bigger, and getting steeper in the negative direction is y gets more and more negatives.
Great. And it should remind us of the one dy dx is equal to 2y, where, the y is the one that's affecting the slope, not the x.
Right. But in a lot of ways, it reminded me of number 1, because number 1 was the sum of x and 1. Even though it's a 90-degree rotation, it was that similar idea of I just have to add 1 and then get this line. And
okay.
Yeah, that was the first thing that jumped in my mind when you said which one is it similar to, as I was thinking the constant with the single variable. So.
Oh. Okay, I'm going to go ahead and see. I don't know why we're having trouble grabbing from each other's screen today, but that's interesting. Yeah, see, you're going to have to stop. Yeah. You have to stop share for me to share.
You had no, I never stopped.
Yeah, no, I'm
you had it. Hi, everyone. Go ahead and grab it, Verge.
I can't. It's not.
You can't. Because I'm not sharing right now, obviously. What did you want to show? Maybe I can pull it up.
I was just gonna go ahead and share. Let's go back to our PowerPoint, because I think I can wrap up verbally. I was just gonna go ahead and share the definition of the slope field again. So maybe we can just go back to our PowerPoint.
Oh, the slope field. We didn't have it in here because you had it written down.
It's okay. Just go back to the PowerPoint.
All right.
So just what we did today was we learned how to sketch slope fields, and remember, a slope field is a graphical representation of a differential equation on a finite set of points in the plane. And we started alluding to this, but slope fields will provide us with information about behavior of the solutions to first order differential equations. And that's really where we're going with the next lesson, is really learning how to interpret slope fields to give us information about the solutions to the differential equations. So in the Dropbox today, you're going to find a couple of different things. You're going to find Nancy's entire handout that she wrote for the entire differential equation unit. And it's going to have what we did today, and then some other things that you can do on your own and check your answers. And then it's also going to have stuff that maybe we haven't quite done yet, solving differential equations, which is coming up next week. And we also have something that Mark wrote, which is a matching activity, which teachers especially will love to download if they don't have it already. What's that, Mark?
Oh, you lagged for a second.
Oh, I was just saying what was in the Dropbox. So like we have Nancy Stevenson's materials, which are pretty broad in scope and includes the sketching slope fields in addition to some other stuff. And then a matching activity that Mark wrote that is really excellent. My students did it this year right before spring break. And it has the slope fields, the differential equations, and some verbal representations. And so teachers and students can find both of those in our Dropbox under 7.3.
And Verge, I'm going to actually take over here for a sec again. This is also in the Dropbox. Are you seeing my Chrome window?
Yep.
Okay. There's a link to this, and if you look at where it says slope field card sort, you don't have to run this. Teachers, I think you can assign it if you're familiar with the Desmos classroom. But if you hit student preview, this has slope fields with equations, and you can drag and drop. And if you think these two go together, you can link them. and set them to the side and later pull them apart. In fact, I think, did we do X plus Y? Was that, or we did negative Y over X, didn't we?
We definitely did negative Y over X.
So
And I
this
believe,
one looks, I think that looked a lot like this. So I
uh-huh.
could grab those two and place those together and set them aside.
Mhm.
And then the card sort in the folder includes a third set of descriptors that you could match up with these if you just wanted to print that page, and you could sit here and look at these once you line them up.
Mhm. This kind of material is excellent for matching activities, sorting activities, and things like that. And thanks for watching. We are so excited to have this opportunity to get with you every day for about 45 minutes. We'll be back live on Monday at 2 p.m. Eastern, 1 p.m. Central, which is our time, or you can watch us after the fact. They'll be posted for viewing after the fact.
And I do want to thank Miss Logsden, who took my slides and put together that Desmos. That was not me generating that. That was Miss Logsden. I believe I'm pronouncing that right. I hope I am.
Yeah. And I don't know if we need to share the last slide as well, in case people missed it from yesterday. And that is that College Board is trying to do everything in their power to make sure students that do not have device and or internet access are able to get that, not just for the exam, but obviously in preparation for the exam. So if you know of somebody who needs that, please go ahead and follow that link below. Mark did it yesterday and it took him to a survey. So you can fill that out for your students, or you can fill it out for your friend, or whatever the situation seems to be. Anything else, Mark?
No, have a good weekend. And I think that
And
sums
for
it up.
these 2 minutes, we'll think that we made no mistakes.
Yes. Spend the next 10 minutes perusing the inbox. Thank you for the jokes. I did get a couple jokes already. So.
Okay, good. We love you guys. Stay
Bye-bye.
safe. Bye.